Welcome to this module of Professor Messer's free CompTIA A+ certification training course, and this module is on network cabling. I'm your host, James Messer, and in this module, we're going to talk about the requirements from CompTIA's 220-601 A+ exam, section 5.1, where we need to describe basic networking concepts, specifically the ones revolving around cabling. Now, you can see that from this list, there's a lot to learn about cabling. We need to learn what Plenum cabling is and how PVC is associated with that. We'll also go through some basic cabling structures like fiber, twisted pair, coaxial cable, and fiber optics. And then we'll do some more private networking type technologies that are used perhaps between two devices like RS-232, USB, and IEEE 1394 or Firewire are some very common networking types. And then we'll look at network connectors so that you understand when you're plugging into a network what you'd expect to see. We'll also step through a couple of troubleshooting scenarios so that you can understand how cabling and troubleshooting cabling can come into play when working with our Windows technologies. When you're working in a home office, your network cabling is relatively simple. You plug in your computer, you might plug it into a cable modem or router, and that's very simple. You've got a simple cable set up, and there aren't a lot of requirements or technical pieces that you have to worry about that. But in a building where a lot of people are working, where it's especially very large buildings, the cabling becomes extremely important, primarily for in case problems are going to occur. The plenum, you'll hear this term, a cable that's rated for plenum. A plenum in a building is the heating and air conditioning space. This air conditioning space and heating space is where usually your cables are run along with it. There's a lot of things that happen up in the ceiling, and that's usually where our cabling is run. And so whenever we talk about needing to put cable in somewhere, we're putting it in that plenum type connection, or we're putting it in the riser where there's a connection between floors. This is where we run cable between the second and third floor or the second and fourth floor. And that goes into the riser, which goes up and down inside of our buildings. Why this is important is because we need to plan for the worst case. Our worst case scenario is going to come when something happens to the building. Primarily, we think about fire in a large building. And we need to make sure that the cabling that we put into a building isn't going to create a problem should there be a fire. What if there was a fire on the fourth floor, and because we were using cabling that could easily catch on fire, it spread the fire down to the second floor because there was a cabling in the riser? Now you're starting to see why understanding more about a plenum rated cable would be so important. These cables are usually wrapped in a cable jacket of polyvinyl chloride, PVC, and they are a type of PVC that is resistant to fire. It's one that is not going to take a fire on one end of the cable and burn all the way to the other side. This is why whenever we look at putting cable into a plenum, putting especially copper or fiber cable into these risers, that it is rated, and it's usually a little more expensive because it's rated this way, not to catch on fire. So even though we're paying a little bit more for that type of cabling, just keep in mind that now we are not going to have to be concerned about fire spreading that way. But if you're working on budgeting a project like this, just keep in mind that the cable that you would normally use to connect devices on a single floor is probably going to be less expensive than the cabling you would use to connect between floors. A cabling type we don't often see in someone's home is fiber, although that's changing rapidly these days. Fiber uses light to communicate. If we run a copper connection like we were using in our traditional Ethernet connectivity, copper connections use an electrical signal. Well, when you get rid of that electrical signal and all you're using is light, you've got a number of advantages here. One of the primary ones is that we can have very high bandwidth applications. Light will move an enormous amount of data, and it will do it in a very short period of time. And so we're finding now that this is a great technology to use to put in areas where a lot of data needs to be transferred at once. And we're also seeing that the fiber connectivity has huge growth potential. What's running at a certain speed of fiber today is probably going to be running a lot faster speed on that fiber a year from now. Our technology is getting better, and the way that we're moving data from these links is becoming much more efficient. As I mentioned, we don't usually see this in the home, in the consumer market, but that's also changing quickly. These days, there is very common services that will bring fiber right to your house, and companies are doing that because with more bandwidth available, I can run fiber to my house where I can have television, I can have my telephone, I can run multiple services over that single wire. So normally we used to have multiple wires coming into our home. Now that's rapidly going away with the advent of fiber type technology coming right into our consumer markets. Although we'd love to have fiber everywhere, it's a little bit expensive. It costs more for the equipment on the ends of the fiber, and the fiber itself is expensive when you compare it to the price of something like copper cabling. And that's why copper cabling's been around for so long. It's relatively inexpensive, and whenever we look at a network, even in the largest enterprises these days, the bulk of what they're running is a copper-based network. Very old styled networking used a coaxial cable. This is very similar to the cable types that are used to bring your cable television into your homes. Coaxial cables have a copper core, a wire in the middle of a piece of this cable, and it's surrounded by shielding and insulation. And it's a very common way to move cable across very large distances, especially for things like cable television, because there's a lot of advantages there. The problem is that it's very bulky, it's very big, and it doesn't have a lot of capabilities for bandwidths and other options. Another type of networking technology is twisted pair technology. You can see a picture of the twisted pair here, and it's a strand of wires that is twisted together as it's put into the cable and brought to you. The reason those wires are twisted up is it tends to have the interference between the different wires diminish. So that allows you to run these cables much longer distances without losing signal. And we've also got different kinds of twisted pair cables. We've got some shielded twisted pairs, or STP. You also have unshielded twisted pair, or UTP. Older style networks have a shielded twisted pair. You don't usually see those commonplace, although they are useful to have in environments where there is a lot of interference that could be used. A manufacturing floor, for instance, is a very good place to have a shielded twisted pair because it won't be subjected to so much interference from the other pieces of machinery that are on the floor. But the less expensive and the most general use of pairs of wires, this is probably what you might have in your home office, is an unshielded twisted pair. This is also what's used very commonly on the floors of most organizations. And there are different categories, different grades. There's category 3, a category 5, category 5E, and category 6. So those categories very similar in their technologies. These categories really are talking about what level speed of technology of signal you're able to put over that wire. So the higher the category, the more capabilities that wire tends to have. It may be a better type of wire. It may be twisted with more twists in the cable. It may be able to support higher speeds. And so these categories allow you to decide for what you're doing, the distances you need to run, and the type of speeds you need. You can decide which type of cable you would like to purchase. Category 3 cable generally is less expensive, for instance, than Category 5 or Category 6. So this helps you understand more about the type of cabling you can expect to see in an environment and the type of cabling that you would use for most types of very common networks. Although our Ethernet networks today are using that cabling that we just saw from the fiber or the copper, it is still possible to network devices together with just a serial cable. Back in the old days when all we used was modems to connect out to these networks, it was this serial connection that was able to do that. Now, what we have done is instead of use a modem today, although you can still certainly use modems to communicate, we can connect devices directly together with an RS-232 cable. All a modem really did was just extend the capabilities of an RS-232 cable. Well, if you just get rid of the modems and connect them up right to each other, it's really the same type of thing. It's very difficult to find software, however, these days that will support a network connection between two devices. But if you try to find some legacy software out there, there is some that can do that. Now, the connectivity over these serial ports, the type of chips that are used, are not very high bandwidth when you compare it to some of the Ethernet technologies we have today. The best you can really get out of a serial port is about 2 megabits per second. That's not horrible, but if we had two devices sitting next to each other and we plugged them directly in via Ethernet, we could have speeds up to 1 gigabit per second. So significantly different type of bandwidth here, but if all you have is a serial port on a legacy device and you want to be able to transfer some data off, your RS-232 connection may be a good option for you. RS-232 connections were great in the day, but they've grown up, and now it's more of a universal serial bus connection. USB is now the new version of that serial connection, and it greatly extends the capabilities you have because you can put more than just a wire or a modem onto this connection. And you can connect it in many different ways. You can go from USB to USB. That's one way to connect two devices together. Well, very often we'll see devices that take a USB connection and turn it into an Ethernet connection that you could put your TCP/IP address cabling on and connect it to the internet. There's also USB to wireless connections, even USB to mobile. The mobile providers today are providing you with a USB dongle you plug in, and now you're able to network on their wireless network. So you could be anywhere. You don't have to be near a home or near an access point. You just have to be anywhere that you can receive a mobile telephone signal. And now you can also use data on your devices. USB is extremely versatile. And these days, that's the type of extensions and extendability that we need to be able to do some of these more advanced networking pieces. Another very common type of networking technology is something called Firewire. This was a technology that was created by Apple, and they used the name Firewire. You will also see this referred to as an IEEE standard called 1394. This IEEE standard, other companies will call it iLink, and they'll use a bunch of other names too, because IEEE 1394 is just a little bit dry. So try to snap it up a bit, give it some other specialized name. So if you see a device that is iLink type port on it, just know that you can also plug your iLink port into a Firewire port or into an IEEE 1394 port. It'll work just fine. No problems there. The Firewire connections, now that they are an IEEE standard, also really work across a very broad range of devices. And they are pretty high speeds. These are 400 megabit and 800 megabit type connections. Firewire itself is slowly diminishing in its popularity because Apple is pulling back a little bit of the support. It used to be that every iPod that came out had a Firewire connection on it. And what Apple has found is that although this is a higher speed and has a number of technologies, advanced technologies in it that go beyond USB, tends to be a lot more prevalent on more devices. And so we're seeing that Firewire may be slowly fading away, but there's still a number of devices that will support it and a number of devices that will allow you to connect two devices up and be able to network over it. If you're plugging into your local Ethernet connection on your motherboard, it's probably a copper connection. And your copper cable probably looks a lot like this cable here. And this is called an RJ45 connection. This RJ45 connection is a little bit different than what we've used on our phone lines, which is this RJ11. So there's different sizes and different number of pins that are used. And if you wanted to be a purist, this technically has a different kind of name associated with it. But in the industry, whenever we say you need an RJ45 connection, this is the type of connection we're talking about. On the other side, if you look on your laptop or on your device, you'll see the ports are a little bit different. And very often you may, if it's in the dark and you're fumbling around, it's very easy to plug an RJ11 cable into an RJ45 connection because that RJ45 is a little bit larger. You obviously can't plug an RJ45 into an RJ11. The RJ45 cable is just too big. So keep in mind that if you're plugging something in, you may want to look for lights that turn on when you plug it in. You want to make sure it goes in there properly, or get a flashlight. Make sure that you've plugged into the right port, because if your device has both of these, it's very easy to make a mistake and plug the wrong cable into the wrong port. When you start working with fiber, what you're going to find is there are many different kinds of fiber connections. And if you're in a situation where somebody's asking you, what kind of fiber link do you have? You're going to need to know the exact physical layout of that fiber connection. So here's a few that you may want to keep in mind. One that is a legacy type connection used on older types of equipment is something called an ST connection. It stands for straight tip, but hardly anyone uses the term straight tip. Usually they say, oh, I've got ST type connections. And those ST connections simply plug in and turn, and we're connected to our fiber equipment using this ST view. A more common, but still a little bit older style technology is one called SC. And again, we're not really calling this the Seaman connector, the subscriber connector, the standard connector. It tends to have many different names. It is simply SC, Sierra Charlie. So if you're on the telephone and you're ordering equipment or you're saying what type you have, ST and SC, you can mix those up very easily. So make sure you're very clear that you're either asking for an ST connection or an SC connection, because as you can see from these pictures, these are very different connections whenever you try to plug them into the devices that you're using. These days, a more common type of connection is something called an LC. That's either stands for lucent connector or local connector, depending on who you talk to. The LC connector is nice because it's a little bit smaller on its form factor, so you can fit more of them into a piece of equipment. And notice it's all molded together. These SCs can come apart. The STs are separated, so very often it's easy to accidentally reverse them, and you're plugging in a send to a send and a receive to receive, and your fiber connection isn't working and you don't know why. The LC helps that by molding everything together so you can't make a mistake. We've also, the newest style that we happen to see is also called MTRJ. This stands for Mechanical Transfer Registered Jack. I doubt you'll ever be asked about that whole name, but you will hear the term MTRJ. The MTRJs are very small. You can see it's very tiny compared to some of these others, and that allows you to fit a lot more type of connections into a piece of equipment. So on some of the more modern types of networking technologies you'll see, the MTRJ tends to be a very common fiber standard that we see. Troubleshooting cabling is a little bit different than troubleshooting anything else on your machine because it's not really software. It's really more like hardware, except it's hardware that's not connected to your computer, at least not per se. The idea is that with cabling, you may need some specialized tools to be able to see, but there are some things that you can do without having specialized equipment that can help you troubleshoot a physical wiring or cabling connection. Cabling is all about that physical connectivity. If we had the best possible world, we would have a cable tester where we plug one side of the tester into one side of the cable, and the other side of the tester into the other side of the cable, and we'd really be able to see exactly the electrical differences between those two and really get some statistics about how good is that cable or how good is that fiber. However, you've got eyes, and those eyes can also be a very good tester. You'd be surprised how many times you show up at someone's desk who's having connectivity issues, and you look down at their connection that plugs into the wall, and their desk is pushed all the way against it, and the cable is really crimped or even pulled from that connection going into the wall. Well, this cabling is a physical connection. It requires that there be an electrical link there. And if there is a crimping of the cable, a crimping of the fiber, or any problem with that physical configuration, you're going to have problems communicating. You'll see that in your operating system statistics. So make sure you look for crimping or connectors that have been pulled out or wires that have just been bent against something else. You may want to replace that cable and see if that resolves some of the problems that you're seeing. Statistics in your operating system can be very useful during this troubleshooting phase. There's something in Windows, we've seen this before in previous modules, called Performance Manager. And what we can do is pull up statistics in Performance Manager, which will tell us how our physical connection is going. It gives us the number of errors across that physical connectivity. That doesn't necessarily mean it's a cable issue. It may be something wrong with the hardware connection that's on our network card, but at least it points us towards more of a physical problem or something that's outside the scope of our operating system applications and utilities that we're using. Let's look at our Performance Manager and see if I'm seeing any problems with the physical connectivity of this device to my network. Our Performance Manager, if you recall, is in our Start Settings Control panel. Inside the Control panel is our Administrative Tools, and inside of the Administrative Tools is our Performance option. And what this pops up is our performance screen. You can see I've got a number of statistics that it's gathering right now, number of pages per second, our average disk information, there's some processor utilization information. None of these have anything to do with the network. Fortunately, we can right mouse click and add counters to this graph. There are a number of performance objects available in Windows, a huge number. You can almost overload yourself with statistics. However, there's a very interesting one for our network interface. And under our network interface, we can not only see some of the bytes and the current bandwidth that we're using over time. This is very useful, maybe useful for some other things, but we can also look at the number of outbound errors and the number of received errors. Now, those may be very good statistics to look at because if we're starting to see physical problems with being able to send or receive data over this network, what's going to happen is we'll start to get errored frames coming in, frames that are garbled, and your computer's not able to put them back together, and ultimately your application has to request that data again. And you'll start to see the counters for those errors, either incoming or outgoing, start to creep up. If that happens, then you can make some assumptions there that there's some type of physical problem. There's some interference, there's a bad cable, or there's a bad interface on your computer. If these counters remain zero, then you can be pretty certain that you're not going to have any type of physical problem during your troubleshooting. You can say that it's not the network, it's not the physical cable, there's some other type of issue I need to troubleshoot. We've looked at a lot of cabling. We've looked at how Plenum type cabling is important in these large environments and how PVC is used on those cables. We've discussed fiber cables, twisted pair, coaxial, and fiber optic connections, but we've also looked at RS-232, USB, and Firewire that are often used from machine to machine. Finally, we discussed some very common network connectors, and we did a little bit of troubleshooting of how we can do over our Windows configuration, get a better understanding of how our physical cabling is performing. For more A+ videos, to participate in our message boards, and much more, you can visit our website, freeaplus.com.